Your headmaster asks for students' performance on the physics test among your classes A and B. So these are the scores for class A, and these are for class B. So how could you explain their performance confidently in front of your headmaster? Which class is better? And how is the distribution of the mark among these two classes? Okay, so we will learn about it in this lesson. Hi, Assalamualaikum. My name is Dr. Kait. So in this lesson, we will learn about data representation. At the end of this lesson, you will be able to construct a histogram, frequency polygons, and box plots. Okay, let's go. Okay, let's us introduce with the descriptive statistics. So what is descriptive statistics? Descriptive statistics is a set of brief coefficients that summarize a given data set. Okay, for example, here you have two data sets, one for 35 students from class A and 30 students from class B. So suppose that we have this set of data. So how can we summarize the data in terms of several coefficients or representation? Okay, the one way that we can represent the data is by a histogram. Alright, so these are two histograms from the same set of data. So these are two histograms. So what is histograms? The characteristic of histogram. So the histogram, it has a what we call intervals. So it has several bar, where each bar it has certain intervals. And then for the vertical axis, there is a frequency. How many the data fall within the interval. Okay, so how we get into this histogram is that when we can create several intervals. In this case, I define the interval for score below 20, 20 to 39, 40 to 59. So we have 5 intervals. Okay, so when we check with the data that we have, for example, for below than 20, so this is the below 20, and then where else, so we have two frequency of which fall into the interval. So the total should be 35. So this total should be 35. Okay, so this interval is also called bin or cells. Okay, so we can define the intervals, but there is a rule of thumb for creating how many intervals that we need for an appropriate histogram. So in this, we can use the relations of how many intervals that we can have by square root of n. N is the number of data set. Sorry, the number of data in the set. In this case, it is 35 because we have 35 data. So n is 35. So the square root is about 6. So the best number of interval that we can have is about 6. So I have here 1, 2, 3, 4, 5. So 5, okay. If too much like this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it is too much, so that one of the several interval, it has no counts in the bin. So it's not appropriate to have such a histogram. So both are the same, but only the, what we can say, the interval is different. Okay, so it seems that 6 interval is better represented the data set. Alright, so let's go to another type of visualization that we can have for representing data, which is frequency polygon. So what is a frequency polygon? Frequency polygon is constructed by connecting the midpoints of the tops of histograms bar. So this is the histogram that we have in the previous slide, but when we connect the midpoint of each bar here, 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 and then we just connect it with a straight line which connect these dots, and then we will remove the bar, then we get the frequency polygon. So this is the frequency polygon. So it looks like a histogram with different look, right? But it depends on you which one is best for your data. Okay, next we go to several coefficients where we can use to represent the characteristic of your data set. So we can have a mean, median, mode, and quartiles. So what is the mean? Mean is the average of data value. Okay, so how can we calculate? So we can calculate by adding up each of the 65 data and divide by 35. So it is summarized by this summation. So in this case, the mean for this data, we can write x mean is 54. Okay, so for class B, the mean is 63.1. So we sum all of it and then divide by the number of the data. So let's go to median. So what is the median? Median is the value at the central of an ordered list. So what does it mean by an ordered list? It means that for these data sets, you have to arrange them from the smallest value to the highest value. So in this case, we reorder into a new list starting from 6 to 98, and then the central the value at the central location is at the number 18, right? So 18, so where is it? This is 10, 11, 12, 13, 14, 15, 16, 17, 18. So this is located at the location 18, the middle of the list. So the median for this class A is 54. So how about for class B? So for class B, it has how many? 30 data. So it should be at 15 or 16. So in the middle between data number 15 or data number 16. So data number 15 is 1, 2, 3, 4, 5. And then data number 16 is 65. Correct? Okay. Okay. So I made some mistakes. It is number 15. So number 15. So 11, 4, 5. So here and here. So this is the median is between this value. So since it is not 65, neither 66, so what we do is that we add up the value at number 15 plus the number at the location 16 divided by 2. So the median is 65.5. So that is the median for the even number of data. So we add two value and then divide by 2. So that is the median. And then we go to mode. Mode is the value of the most frequent. So when we go to number set class A, so which one it appear the most? Okay, so this is 50. Where is it? 56, 3 times. This is also 3 times. 3 times. So I guess if I'm not mistaken, so we have several mode value. We have 56, we have 67. Okay, we have 67, and then we have 634. Okay. Okay, so we have three value of the most frequent. So it's okay because because we have three modes with the same highest frequent. For class B, we have 45. This is the mode. Okay, the mode is 45 for class B. Again, then we go to first quartile and the second quartile. The first quartile is the value of 1/4 of an ordered list of value. So in this case, where is the first quartile? Okay, so the easiest way to get that is by calculating 1/4 times 35. So this is 8.75. Then it is at 8, between 8 and 9. Okay, so 1, 2, 3, so 8 to 9. So here, so I use the different color. So here it is between these two values. So we just take 34 plus 35, right? So the first quartile is 34.5. Okay, right? 34.5. And the second quartile, how to calculate? So the third quartile is 3/4 times 35. So we have 26.25. That means it is between 26 and 27. So 26, where is it? 20. So 20, 20, 26, 5, 6, 7. So this one 67. So since they have the same value, 66 and 67 and 67. So the third quartile, the third quartile is also just 67. Okay, so the second quartile is just a median. It's just the same. And lastly, interquartile. Interquartile is the third quartile. So this value 67 minus 34.5. Okay, so this is the range between interquartile is we deduct subtract 67 minus 34.5. It is 32.5. Okay, so these all the coefficient here can be represented in a box plot. So this is the box plot. Okay, so for the set data set A, we can have this is 98, this is 6, the median was, how much was it? 54, right? 54, and this is 35, sorry, this is 67, and this is 34.5. Okay, so this all of this value can be represented by a box plot. Okay, so let's look what's the advantage of this box plot. So for example, we have again the same class. Okay, the same class. Then we can compare between these two. So this the cross is represent the mean. Okay, so we have highest, the third quartile, second quartile or median, first quartile, and the lowest. So between these two class, we can estimate the performance of academic performance between these two class. So which one's better? Which one is average? Okay, which one is highest? Okay, even though class B, the highest is lower than class B, but in cumulatively they perform better because the mean is higher, right? The mean is higher, and then the median is also higher. But when you compare between this what we call the mean and the median, so for group A is okay, but from group B, it seems that many of the students perform more than half perform better, which high which high score. We can say like that. Okay, so this is the summary of the coefficients between group A and group B, but then we can represent them in a visual way. So when you are asked to report the performance of the students, you can use either histogram, frequency polygon, or box plots. So it depends on how you can explain to your headmaster. Okay, in the next lesson, we will look into another strategy of evaluating the performance of your class in academic. Okay, bye.